The morning of February 24th, 1943 broke cold and clear over Burbank, California. In a corner of Lockheed's test facility, a battered P-38E sat waiting, its aluminum skin scarred by months of experimental punishment, its engines already having pushed beyond their design limits dozens of times. This was the K-Mule, a test airframe that had been modified, rebuilt, and beaten into submission in the name of research. But on this particular morning, it carried something different, something that wasn't supposed to be there. The propellers were wrong. Not wrong in the sense of being damaged or incorrectly installed. Wrong in that they hadn't been approved by the Army Air Forces, hadn't been ordered through proper channels, and certainly hadn't been authorized for installation on a Lightning. They were Hamilton Standard hydromatic propellers, the broad-bladed paddle type that had recently transformed the Republic P-47 Thunderbolt from a capable fighter into a climbing demon, and someone at Lockheed, some engineer or mechanic whose name has been lost to history, had decided to see what would happen if you bolted them onto a P-38. This decision, made somewhere between official oversight and outright insubordination, would produce the finest performing fighter aircraft of the war, and then bureaucracy would kill it. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Lockheed P-38 Lightning had entered service in 1941 as a revolution in fighter design. Twin-boomed, twin-engined, with its armament concentrated in the nose pod, where the pilot sat between two massive Allison V-1710 engines, it looked like nothing else in the sky. It was fast, nearly 400 miles per hour in level flight. It had range that single-engine fighters could only dream of, and with two engines, it gave pilots crossing the vast Pacific a comforting redundancy that meant the difference between life and death when hundreds of miles from the nearest airstrip. But by early 1943, the Lightning's limitations had become painfully apparent. In Europe, it struggled in the freezing air above 30,000 feet, where German fighters routinely operated. The turbo-superchargers, those complex General Electric units that gave the Lightning its high-altitude performance, had an unfortunate tendency to malfunction in extreme cold, leaving pilots with wildly fluctuating power or, in the worst cases, complete engine failure at the exact moment they needed every available ounce of thrust. The intercooler system, designed for the earlier, less powerful engines, couldn't properly cool the charge air at high boost levels, leading to detonation and catastrophic engine damage. And the climb rate, while respectable, simply couldn't match what pilots needed when German Focke-Wulfs or Messerschmitts dove from above. Most frustrating of all was the sensation that the Lightning was somehow holding back. The airframe itself was sound. Kelly Johnson's unconventional design had proven remarkably robust. The engines, when properly managed, were reliable enough. But there was a ceiling to the Lightning's performance that seemed artificial, as though the airplane were capable of more, but was being held to some arbitrary standard that had nothing to do with the metal and physics of flight. At Lockheed, the engineers knew this feeling wasn't imagination. They had been watching the P-47 program with intense interest, particularly the modifications made to the P-47C model in mid-1942. The installation of those Hamilton Standard high-activity propellers had produced dramatic improvements in the Thunderbolt's climb rate and acceleration improvements that came not from more powerful engines, but simply from more efficient propellers, blades designed to bite deeper into the air and convert horsepower into thrust with less waste. The propellers required larger diameter spinners to house their mechanism, which meant modified cowlings and a slightly different thrust line. But the performance gains were undeniable. Someone at Lockheed, and the historical record does not preserve exactly who deserves credit or blame, decided that if paddle blade propellers could transform a P-47, they might do even more for a Lightning. The P-38E test mule sitting in the experimental hangar was already a composite of modifications. It had been used to test the P-38J's new chin-mounted intercooler installation, and its airframe bore the scars and modifications of countless other trials. It still carried its piggyback configuration, a second seat behind the pilot where an observer or engineer could ride during test flights, scribbling notes and monitoring instruments that the pilot couldn't watch while flying. The propellers were installed without fanfare. Hand-formed sheet steel cowlings were fabricated to blend the larger spinners into the nacelles, giving the aircraft a rough, almost improvised appearance. The fit wasn't perfect, gaps existed where production cowlings would have sealed smoothly, and the entire installation looked like exactly what it was, a field modification done without the blessing of official approval. But on the morning of February 24th, with a Lockheed test observer strapped into the rear seat and an Army Air Forces representative watching from the ground, the K-Mule's engines coughed to life. The sound was different. The propeller's broader chord and altered pitch produced a deeper tone, a more aggressive bite, as they clawed through the air even at idle. The pilot, his name too, lost to incomplete records, ran through his pre-flight checks, noting the changed handling characteristics as the propeller's greater mass affected the engine's response. Then he released the brakes and began his takeoff roll. The acceleration was immediately apparent. Where a standard Lightning would have taken a measured, deliberate pace down the runway, the K-Mule seemed to leap forward, the new propellers converting the Allison engine's torque into forward motion with startling efficiency. The tail came up quickly. The main wheels lifted, and then the Lightning was climbing, its nose pitched up at an angle that would have seemed aggressive in any other variant. In the rear seat, the observer watched his instruments and felt his stomach sink as the altimeter unwound in reverse. 1,000 feet, 2,000, 5,000. The rate of climb was extraordinary, far better than any production Lightning could achieve. But it was at altitude where the real test would come. The question wasn't whether the new propellers improved low-altitude performance. The question was whether they could push the Lightning into the thin air where enemy fighters operated, where the turbo-superchargers had to work their hardest, and where every pound of drag and every wasted horsepower showed itself in diminished performance. At 20,000 feet, the K-Mule was still climbing strongly. At 30,000 feet, where many Lightnings would have been gasping for air, their climb rate reduced to a few hundred feet per minute. The modified aircraft continued upward with almost casual ease. At 40,000 feet, the air was thin enough that the wings' lift came grudgingly, each increment of altitude requiring more time and fuel. But still, the K-Mule climbed. At 45,000 feet, the pilot leveled off. Through the canopy, the sky had darkened to a deep purple blue, the curvature of the earth visible at the horizon. Below, California's landscape had resolved into an abstract pattern of browns and greens, the cities reduced to smudges of grey. At this altitude, few aircraft could operate. Even the fearsome German Focke-Wulf Tar 152, designed specifically for high-altitude interception, struggled to reach these heights, and the K-Mule had climbed here on a hot, humid day, when air density was at its lowest and performance was at its worst. On a standard day, Lockheed's engineers estimated, the aircraft could have reached 48,000 feet or higher. The test flight continued for another hour, with the pilot putting the Lightning through a series of handling tests, noting the aircraft's behavior at altitude, its acceleration, its turn performance. When he finally descended and landed back at Burbank, his report was succinct and devastating in its implications. The modified Lightning was the best-performing fighter he had ever flown. The success of the K-Mule prompted an immediate decision at Lockheed. If a battered test airframe with hand-formed cowlings and improvised modifications could perform this well, what could a purpose-built Lightning achieve? The 12th G model Lightning, originally set aside as a P-38J prototype airframe number 422-81, Army Air Forces serial number 42-13558, was pulled from the production line and designated for conversion. This aircraft would be no improvised test bed. It would be the P-38K-1LO, a fully developed variant, incorporating not just the Hamilton standard propellers, but also the latest Allison V17 1075/77 engines. The 15R and L models rated at 1875 brake horsepower at war emergency power. These engines weren't simply more powerful, they were geared differently, with a reduction ratio of 2.36 to 1 instead of the standard Lightning's 2 to 1. This meant the propellers turned more slowly relative to the engine's crankshaft, allowing the broader blades to operate at their optimal efficiency range. It also meant the thrust line was slightly higher than on standard Lightnings, necessitating redesigned cowlings that blended the new spinners and changed thrust line into a cohesive whole. The result was an aircraft that looked almost identical to the P-38J then entering production, but whose performance would prove to be in an entirely different category. The P-38K1 began its test program in late February 1943, continuing through the end of April. Each flight added to the mountain of data, suggesting that Lockheed had created something extraordinary. At military power, the maximum continuous setting that pilots could sustain without risking engine damage, the K1 reached 432 miles per hour at its critical altitude of 29,600 feet. This was 40 miles per hour faster than a P-38J could achieve at the same altitude. At 40,000 feet, the speed advantage was even more pronounced. And under war emergency power, the setting used only in combat when survival trumped all other concerns. The K1 was predicted to exceed 450 miles per hour. The climb rate was even more remarkable. Fully loaded with fuel, ammunition, and all combat equipment, the P-38K1 could climb at 4,800 feet per minute from a standing start on the runway. It could reach 20,000 feet in just 5 minutes, the time it took a pilot to complete his post-takeoff checks and get his bearings. In war emergency power, the initial climb rate was predicted to exceed 5,000 feet per minute, a rate that would allow a Lightning to climb from sea level to 30,000 feet in 6 minutes, reaching combat altitude before enemy fighters could intercept bombers or before attacking aircraft could escape to safety. This performance didn't come from exotic materials or revolutionary aerodynamics. It came from propellers, from the simple recognition that the method by which an engine's power was converted into thrust mattered as much as the power itself. The paddle blade Hamilton standard propellers were more efficient than the standard Curtiss electric units, particularly at high altitude, where every improvement in efficiency translated into dramatic gains in performance. Combined with the higher-geared engines, they transformed the Lightning from a capable fighter into a dominant one. In September 1943, the P-38K1 was delivered to Eglin Field in Florida for official Army Air Forces evaluation. There, it was flown in comparative trials against the North American P-51B Mustang and the latest version of the P-47 Thunderbolt, the P-47D. These were the fighters then being rushed into production, the aircraft that would carry the burden of America's air war over Europe and the Pacific. The evaluation was meant to be comprehensive, testing not just maximum speed and climb rate, but turn performance, pilot workload, maintainability, and all the other factors that determined whether an aircraft would succeed in combat. The P-38K1 proved superior in nearly every category. It climbed faster than either the Mustang or the Thunderbolt. Its high-altitude performance exceeded both. Its twin-engine reliability gave it an advantage that no single-engine fighter could match. Even its firepower, 450 caliber machine guns and a 20mm cannon, all concentrated in the nose, where convergence and trajectory drop weren't factors, was acknowledged as superior to the wing-mounted guns of its competitors. The test pilots' reports were uniformly positive. Some were enthusiastic to the point of advocacy, recommending immediate production and deployment. None of it mattered. The War Production Board, the civilian agency responsible for coordinating America's industrial output, refused to authorize production of the P-38K. The reason given was simple and, in its own way, logical. Converting the production lines would require a halt of 2 to 3 weeks, while new tooling was installed, new cowlings were set up for manufacture, and workers were trained on the modified procedures. During those 2 to 3 weeks, no Lightnings would be produced. The ongoing battles in Europe and the Pacific demanded a constant stream of fighters, and any interruption, no matter how brief, was deemed unacceptable. Lockheed's engineers protested. They pointed to the superior performance. They noted that the P-38K-1 would give American pilots a decisive advantage in combat. They argued that the 2 to 3 week delay would be more than compensated for by the increased effectiveness of the aircraft produced afterward. Some pointed out, though perhaps not in official reports, that pilots' lives were at stake, that the superior climb rate alone could mean the difference between reaching altitude before being bounced by German fighters or being caught low and slow where the Lightning's advantages evaporated. The War Production Board was unmoved. The P-51 was already in production. The P-47 was rolling off assembly lines in increasing numbers. Both were good enough. The Lightning, in its standard J and L variants, was good enough. The marginal improvement offered by the K model didn't justify the disruption to production schedules that had been carefully coordinated across dozens of factories and hundreds of subcontractors. And so the P-38K-1 was relegated to storage. The test data was filed away. The propellers that had transformed the Lightning were installed on other aircraft types, where they improved performance without requiring production line changes. And P-38 pilots continued to fly J and L models, whose performance, while adequate, was demonstrably inferior to what could have been achieved. In the Pacific theater, where the Lightning found its greatest success, pilots developed their own modifications to extract more performance from their aircraft. Charles Lindbergh, the famous aviator who spent 6 months in 1944 as a civilian technical representative for United Aircraft, taught Lightning pilots fuel management techniques that the Army Air Forces had explicitly discouraged. By reducing engine RPM to 1600, a setting that pilots had been taught would cause engine damage while maintaining manifold pressure at 30 inches of mercury and running the mixture in auto-lean instead of auto-rich, Lindbergh demonstrated that Lightnings could extend their range by 400 miles or more. After several missions where he consistently returned with significantly more fuel than any other pilot in his flight, skeptical Lightning pilots began adopting his techniques. The Army Air Forces eventually acknowledged that the methods worked, though they never officially changed their pilot training materials. Other modifications happened at the field level, implemented by crew chiefs and mechanics who understood their aircraft better than any engineer in Burbank. Throttle stops the mechanical limits that prevented pilots from advancing the throttles. Beyond approved manifold pressure settings were modified or removed entirely in some squadrons, allowing pilots to push their engines to 70 inches of mercury instead of the approved 60 or present of the 60 of the mercury, 64. This provided substantially more power, particularly at high altitude where every additional inch of manifold pressure translated into more speed and climb rate. It also risked engine damage if used improperly, but in combat, the choice between possibly damaging an engine and definitely being shot down was an easy one. These field modifications were never officially sanctioned. They existed in a grey area between regulation and necessity, between what the manuals said should be done and what combat experience showed must be done. Crew chiefs who removed throttle stops didn't request permission from higher headquarters. They simply did it, then noted in their maintenance logs that engines were adjusted for optimal performance or used similarly vague language that would pass casual inspection. Pilots who used Lindbergh's fuel management techniques didn't advertise the fact in their after-action reports. They simply flew longer missions and came home when other pilots would have been swimming. This tension between official procedure and field innovation defined much of the Lightning's service history. The aircraft that pilots actually flew bore only passing resemblance to the aircraft described in Army Air Force's technical manuals. Every squadron had its own modifications, its own tricks for extracting additional performance or reliability. Some worked, some didn't. A few, like Lindbergh's fuel management and the paddle blade propellers, worked spectacularly, but were never officially adopted, because doing so would have required admitting that the official procedures were wrong. The story of the P-38K represents this tension in its purest form. Here was an aircraft that was demonstrably superior to anything else in American service. Its performance advantages weren't marginal or debatable. They were massive and documented. Test pilots had flown it. Army Air Force's evaluators had compared it directly against the P-51 and P-47 and found it better. And yet, it was rejected, not because it didn't work, but because producing it would have been inconvenient. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The human cost of this decision cannot be calculated precisely, but it can be estimated. Every pilot who was caught low by German fighters because his Lightning couldn't climb fast enough. Every bomber crew that died because their fighter escort couldn't reach them at altitude. Every mission that had to be scrubbed or shortened because Lightnings lacked the range to make it to the target and back. Some portion of these losses could have been prevented if the P-38K had gone into production in mid-1943, when the air war over Europe was reaching its peak and when every advantage mattered. The War Production Board's calculus was purely industrial: production numbers, factory utilization rates, minimum disruption. In this calculus, the individual pilot was an abstraction, a unit of personnel, no different from a unit of aluminum or a barrel of oil. The board members who made the decision probably never flew in a Lightning, never climbed to altitude while watching enemy fighters above them, never felt the sick certainty that their aircraft simply couldn't climb fast enough to avoid being bounced. To them, the P-38K was a line item in a production schedule, and the 2 to 3 week delay was unacceptable regardless of the performance advantages. To the mechanics at Lockheed who had modified the K-Mule, to the test pilots who had flown the P-38K-1 and felt its extraordinary performance, the decision must have felt like betrayal. They had created something genuinely superior, something that would have saved lives and won battles, and it was being rejected for reasons that had nothing to do with the aircraft itself. The paddle blade propellers that had transformed the Lightning were available. The engine modifications were understood. The cowling changes required were straightforward. Everything needed to produce the P-38K existed. Everything except the will to temporarily slow production. In Europe, Lightning pilots continued to struggle with their J and L models. The gradual improvements introduced in late 1943 and early 1944, better cockpit heating, improved dive flaps, hydraulically boosted ailerons addressed some of the Lightning's problems, but didn't fundamentally change its performance envelope. The P-51D Mustang, with its superior speed and simpler maintenance, began replacing Lightnings in the 8th Air Force's fighter groups. By mid-1944, the Lightning was being phased out of European operations, its reputation tarnished by 2 years of struggling in an environment where its advantages were negated and its limitations were magnified. In the Pacific, the Lightning remained dominant. The warm temperatures eliminated the cold weather problems that had plagued European operations. The vast distances played to the Lightning's range advantage, and Japanese fighters, while nimble and dangerous in a turning fight, couldn't match the Lightning's speed or high-altitude performance. P-38 pilots in the Pacific became aces. Richard Bong shot down 40 Japanese aircraft flying a Lightning. Thomas Maguire scored 38 kills. Charles MacDonald, who commanded the 475th Fighter Group, got 27. But even in the Pacific, pilots knew their aircraft could have been better. They knew about the P-38K, even if they'd never seen one. News traveled through the fighter community, passed along in letters and conversations, and the informal networks that existed between squadrons. They knew that somewhere in California, There was a Lightning that could climb to 45,000 feet, that could reach 20,000 feet in 5 minutes, that was faster than anything else America was producing. And they knew it would never be built. The K-Mule, the battered P-38E that had started it, all eventually disappeared into storage or was scrapped. The P-38K-1, the single production intent aircraft that had proven the concept, met a similar fate. No photographs of the K-1 are known to survive. The only image that remains is a single shot of the K-Mule, its rough cowlings and modified spinners visible, standing in as a proxy for the aircraft that might have been. In the decades after the war, aviation historians and P-38 enthusiasts would occasionally stumble across references to the P-38K in declassified documents or in the memoirs of test pilots. They would find the performance data, the climb rates, the speeds, the altitude capabilities, and wonder why such an aircraft had never entered production. The explanations varied. Some blamed bureaucratic inertia, others pointed to the success of the P-51 as making the P-38K unnecessary. Still others suggested that the war's outcome was never truly in doubt by 1943, making improvements to existing types less urgent than they might otherwise have been. But the real explanation was simpler and more frustrating. The P-38K was rejected because accepting it would have been inconvenient. 2 to 3 weeks of lost production, in the War Production Board's assessment, outweighed any performance advantage. The board made this calculation in an office in Washington, reviewing production charts and factory capacity numbers. They made it without considering that somewhere over Germany or the Pacific, a pilot was climbing to altitude in a Lightning that was good but not good enough, while an enemy fighter above him enjoyed advantages that could have been eliminated if only his aircraft had been fitted with better propellers. The P-38 story, then, is not just about an innovative aircraft design or about the twin-boomed fighter that looked like no other plane in the sky. It's about the gap between what could have been done and what was done, between the innovations that mechanics and engineers and pilots knew were possible, and the decisions made by bureaucrats whose primary concern was maintaining production schedules. It's about modification and improvement happening despite official channels rather than because of them. About field crews who removed throttle stops and pilots who adopted fuel management techniques that violated official procedure because those modifications and techniques kept them alive. And at the center of it all, the ghost of the P-38K, the Lightning that climbed to 45,000 feet on paddle blade propellers that weren't supposed to be there, that proved itself superior to every other American fighter in official trials, and that was rejected anyway because approving it would have required stopping the production line for 2 to 3 weeks. For the rest of the war, P-38 pilots flew aircraft that were merely good. They won battles and achieved victories and came home, alive more often than they might have in lesser aircraft. But they did it knowing that something better had existed, had been tested and proven, and had been put aside because bureaucracy values consistency more than excellence. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.